All right, welcome back, guys. So we're going to do 2.3 today. And so, what we saw in 2.1 and 2.2 were just graphical ways in which we can display information and also ways to organize information, our data with those histograms. So let's say that we've taken a sample, we've gathered our data, and now we want to find some descriptive statistics. Okay, so that's kind of what we're going to talk about today. These are called, if you look here in the notes, measures of central tendency. Okay, so if you think back to those dot plots or those stem and leaf diagrams that we did, when you make one of those, you automatically get to see how the data is distributed or spread out. And every data set is going to have a center, okay, a center of mass in a sense. And that's kind of one of the things we're going to talk about today. All right, so some of these descriptive statistics here, guys, are going to be called the mean, which is a fancy name for average, the median, you've probably heard that term before, and the mode of either a population or a sample. Okay, of course, typically we're working with data from a sample, right? Not an actual. The data comes from a population, but it's a subset. And then we're also going to look at how to find a weighted mean of a data set. And you actually do this when you calculate the grade. If we were to calculate your grade in this course, we would be finding a weighted mean. It's called weighted because we give a weight or a percentage to each of those different categories, like the homework, the quizzes, the tests, the final, the discussion board, and then the project. And then how to estimate the sample mean of grouped data. Okay, so if you had a data set but you didn't actually know the actual data, you just had like a frequency table, okay, or a histogram, or a frequency table rather, not a histogram, and you just knew how many data values were within this certain interval or within this certain class, you can still estimate what the mean of that data set would be without actually knowing the actual data itself. And we'll look at that. And then finally, we're going to talk about the shape of these different distributions. So, when you go out and gather data, it's always going to be distributed differently. And we're going to look at some of the common shapes that the distributions or that the dot plots make. Okay, some of them are going to be close to symmetric, uniform, or skewed. And then we're going to see how what things in a data set could affect the mean and the median. All right, well, let's get started. So the first thing we'll talk about is the mean. Okay, so as you can see here, it is the sum of all the data entries divided by the number of entries. So like I said, this is just a term that we use in statistics to refer to average. So to find the mean of the data set, you can use either one of these formulas, depending on if your data represents a population or a sample. And notice too here, guys, we use mu. That's what this lowercase Greek letter is called. It's right here in the notes. It's spelled mu and pronounced mu. So this Greek letter always refers to the population mean. And you find it by summing up all your x's and dividing that by the size of the population, this capital N. So contrast capital N with lowercase n. Capital N always refers to the size of a population, and lowercase n always refers to the size of a sample. And then the mean for a sample, we use x bar, an x with a bar over it. And then this symbol right here, this is what we call sigma. This is in the notes as well. Okay, it's right here. It indicates a summation. So when you see something like this, the sum of x, that means you're adding up all the x values, and the x values are your actual data points or your data values, okay? So this is a mathematical way of saying that you're going to sum all the data entries and you're going to divide by the number of data entries in the population or in the sample, okay? Okay, so that's what the mean is. We'll look at an example here in a minute. Now, what about the median? When you hear the word median, guys, you want to think about middle. You may have heard that term used before. I know I hear it a lot, like on the national news. They may say the median household income is $60,000. So what that means is 50% of all household incomes fall below $60,000, and 50% of all household incomes are above $60,000, okay? So $60,000 is in the middle. All those other data values, you got 50% below and 50% above, okay? So it literally splits the data set into two. It's the same as the 50th percentile, in other words. Okay. Now to find it, if you were going to try to find it by hand and you had a data set, you would list all of the data in either ascending or descending order. Ascending order would be more commonplace. You would list the data in ascending order, and then you would find the data value that's in the middle. And there's a couple cases here. If you had an odd number of data values, the median will be the exact middle data value. But if you have an even number of entries, then the median is going to be the mean of the two middle data entries. Because if you have an even number of data entries, then there will be two that are in the middle. So then you average those two. And whatever that average is, that would be the median. Okay? And like I said, you want to think about the median as meaning middle. And remember, too, that when you're finding it by hand, if you're finding it by hand, you want to put the data in order to do that. All right, and then the last thing that we're going to talk about is something called the mode. Now, this is typically not used all that much. This would be more appropriate for qualitative data. So if you're going around asking people what their favorite color is, then the mode, it's going to be the data entry that occurs the most with the greatest frequency. So if most of the people you survey say that blue is their favorite color, then blue would be the mode for that data set. But remember, in that example, the data is qualitative. But the mode does exist for quantitative data as well. It would just be the number that occurs the most. And data sets don't have to have just one mode. You can have two modes or three modes, okay? In situations like that, if you had a data set that had two modes, that would be called bimodal. Or if it had three modes, it would be called trimodal, okay, etc. So for example, if two data entries have the same frequency, then the data set is called bimodal. Let's see. And yeah, like I said, it is the only measure of central tendency that can be used to describe data at the nominal level of measurement. So remember, nominal, that was that lowest level of measurement, typically used for qualitative data. All right, so now what we're going to do is we're going to find these three descriptive statistics from a data set. So it says the points scored by the winning teams in the Super Bowls for the National Football League 2005 through 2020 seasons are listed. Okay, so we want to find the mean, the median, and the mode. Well, if you're doing this by hand, so this is a sample, right? Because this is not This is not the high score from all of the seasons. This is just from the seasons from 2005 to 2020. So this is a sample. So the mean of this sample, denoted by X bar, is going to be the sum of all of these data values divided by the number of data values. Okay. So guys, you can do this in the calculator. Okay. Instead of me writing every single one of these out and punching every individual one into my calculator and then hitting enter, and then dividing by the number that we have listed here, the calculator will perform or will calculate these descriptive statistics for a data set. Okay, and I'm going to show you how to do that. What you want to do is come over here to this stat key, and you're going to hit enter, or you're just going to press it. Okay, and then you're going to select edit. And so by doing this, I'm actually, well, I'm in list 2 instead of list 1. It doesn't matter what list you're in, but I do want to delete all the data that's in this list. There we go. Well, I think I actually deleted the list, but yeah. There's another way to do this. It's using the clear button, not the delete button. Okay, so you can see I'm here in list 1. Let's scroll over. Yours may look a little different. Okay, so I'm going to input these data. So 21, each time you just hit enter. 29, 17, 27, we've got two 31s. So 31 might end up being our mode just by looking at this data. Okay, I'm going to keep on going. You know, at some point you're going to have to put data into some kind of software, be it a calculator like this or Excel. Okay, you just have to kind of type it out. 13, we've got another 31. Yeah, so the modes, we've got a fourth 31 as well, so the mode is probably going to be 31. Okay. All right, so once you've got your data in your list, now what you're going to do is go back to stat, and you're going to scroll to the right where it says calculate. And one variable statistics is highlighted, and that's what you're going to hit enter. And you want to make sure that this is you have listed here the list that you're using. Well, as you saw, I put my data in list 1, and I have list 2 listed. So I need to put in list 1. So one of the ways I can do that is I can come above the stat key where it says list, and to access that I can hit second and then the stat key. That'll take me to this list of lists, and I can hit enter for list 1. Okay, and I'll scroll down and I'll hit calculate, and what it does, it'll find all these statistics. So you can see at the very top it tells me what X bar is, which is the mean of this data set. It says it's 28.5, okay? But it also tells me what the sum of x's is. It says the sum of x's would be 456. So that's what I'm going to put in my notes. And then it'll tell us the sample size. If you look right here, it says n is equal to 16. Okay? And 456 divided by 16 is 28.5. Okay, I'm going to put in here in the notes that we're using the calculator. All right, so that's the average. That's the center of this distribution, or one statistic that we use to call the center. Okay. Now the other one is the median. So if you were going to find the median by hand, what you would do is you would relist all of this data from smallest to largest. I don't know that I'm going to do all of that. So you'd have 13, and then the next one I think is going to be 17. And what's after 17? Maybe a couple 21s, okay, etc. All the way to the largest data value, which seems to be 43, okay? And then you would look and see which one's in the middle. Well, in this case, there would be two that are in the middle. Because of this one, guys, I am actually going to do it just because I want to be, I don't want there to be any ambiguity, okay? And it's a good idea that when you are doing this, you can cross off these values. I think that I've told you that before. And where's the other 21? Okay. And then what do we have? We've got a 24. Okay. We have got a 27, a 28, and 29. And then we get into the 30s, and we've got 1, 2, 3, 4 31s. And then we've got 2 34s. You can see I'm actually running out of room here. And then we've got a 41 and a 43. So this is kind of unfortunate. But all right. So you would look to see what value or values are in the middle. And so typically what I'll do is I'll just start crossing one off from each end, okay, until I get to the middle. So we're getting close, and you can see that actually there's two in the middle, okay? So the median would be the average of these two. So 29 plus 31 divided by 2 is going to be 60 divided by 2, which is 30. So 30 is the median. Now I want to show you, if I go back to the calculator and I scroll down, it'll also give me the median. See, it's 30, okay? Now, the calculator will not give us the mode. So for the mode, you just have to inspect, although Excel will do it, and I'll show you that here in just a second. The mode, I think, as you guys can see, is 31, because it occurs more than any other value. It occurred 4 times, okay? So these would be these 3 descriptive statistics for this particular data set. So you could say that from the years 2005 to 2020, the average winning football score was 28.5 or 30 or 31. It depends on which statistic you use to call the average. Okay, and some, depending on how the data is distributed, some of these are better than the others in capturing that idea of average, or that idea of centeredness, okay? All right, now I want to show you in Excel. So I pulled up Excel right here. I've already got these data values put in, and notice I didn't order them or anything. What you can do after putting your data values in, what I did right here was I came over here, whoops, no, but let me not hit that. Well, let me delete this cell, okay? All right, so I've deleted it, so I'm going to come over here, I'm going to click equals. Now I can tell Excel to calculate something from this column of data. If I come over here, you guys will probably have to come down here where it says more functions and make sure that you have this category selected. By default, I don't think it's there, but you can select it, statistical. That way it'll give you a list of statistical operations instead of other types of operations. Okay, so I click OK. Now I can drag from that top data cell down to the bottom data cell. I can click OK. Well, this one's not what I wanted. Let me try this again. I hit equals. Now come over here, okay? And you can click on more functions. And since I've got statistical selected, I can scroll up and down through here. And so the first thing I'm going to do is try to find the mean. It's not actually listed as mean. It's listed as the average, okay? So click on average, then click OK. Now, when this box pops up, that's when you want to actually click on the first cell where your data is and then drag it down to the last cell, okay? And it's telling Excel to go from A1 all the way down here to A16. That's where your data is listed. And so when it goes to find the average, it'll be referencing this data, all the data that's in these cells. And then click OK. You can see it'll give us 28.5. And then you could come over here and you could do the same thing for the median. I'm going to delete this so that I can show you again. So I'll hit equals, come back over here, click on more functions, scroll down to where it says median right here, click OK. Do the same thing, drag this over your data and then click OK, and it'll compute the median from all this data, and you can see we get 30 again, don't we? And then this last one here, let's do the mode for it. So I'll say equals, and come back over here. When I come down here to mode, there's two of them. There's multi and there's single. You want to click on multi. What this allows Excel to do is if there's more than one mode, it'll tell you. Okay, click OK, drag that same. It gives me 31, and that's what we got, wasn't it, earlier? Okay. So anyway, I wanted to show you that. We'll probably use it some more in the next section. Excel, guys, is great. It's fun to work with. It's got a tremendous amount of power. You know, you can make budgets. You can set up all kinds of templates and stuff. But anyway, so this is an option for you if you don't want to use the calculator. But anyway, all right, well, let's continue then. Okay, so like I said, each measure of central tendency has its advantages and disadvantages. So those three measures are the mean, the median, and the mode. All right, so the first thing we want to talk about is something called an outlier. So as the name suggests, an outlier, guys, is a data entry that's far removed from the rest of the data. Okay, so for example, let's say we were taking a sample, or we were measuring how tall all the students in this class are. Well, if there's somebody in this class that's 7 feet tall, that would be an outlier. Okay, most everybody in here is going to be probably evenly distributed about whatever's average. There'd be some below and some above, but like I said, if there's anybody that's 7 feet or anybody that's only 5 feet, those are probably going to be outliers. And so here's an example. Here's a little data set, And you can see 77 is an outlier. It's so far removed. It's so different from these other values. And an outlier can greatly affect the way your data, it can affect the mean. Okay. So it says, which measure of central tendency is most affected by outliers? It's the mean. I know in one of my classes, we do a little introduction to statistics, and I ask them, we pretend that we're finding the annual salary of all the students in the room, okay? So that might range from $10,000 to, $50,000, something like that. And then I'll ask them, well, what if somebody like Bill Gates or Elon Musk or Jeff Bezos comes in the room? Do you think that would affect the average? And the answer is yes, it would greatly affect the average. In fact, it would make all the students look like millionaires. The average would be in the millions, even though there's only one person in there that makes much money, okay? So an outlier will greatly affect the mean. It doesn't typically affect the median because the median is just the number that's in the middle. So it doesn't matter if that outlier is on one side. It doesn't matter how far away it is. It's still just on one side of the median, okay? And then the mode as well is typically not influenced by an outlier. All right, so here's an example. Let me zoom in a little bit. So what we have here is a histogram, if you guys remember that, from 2.1. And the data that we're using is ages of students in a class. So you can sort of see how the data is spread out. You can see the frequency. Now in this case, the class is just a single year. So 20, 21, 22, 23, 24, and 25. But look, there's somebody in the room or in the class that's 65. So this is an outlier. And notice what happens. Just by looking at this portion of the data, you would think the mean would be right here in the middle, okay, right there. But because of this outlier, that actually shifts the mean to the right. So now it's way over here, it gets pulled. And so it gives us an unrealistic idea of what the average age is. It tells us the average age is maybe around 25, 24, 25, when you can see clearly most of the data or most of the students in this class are below 25, okay? And also you can see that the median is pretty much still in the middle, so it's more or less unchanged. But but an outlier can really influence the mean greatly. Now, if this were a class of seniors and all your data was over here and then you had somebody that was only 20, that would be an outlier, and it would be just the opposite. The mean would get pulled down, and it would make it look like all these seniors were younger than they actually are. Okay. All right. Okay. Let's go to this next thing. So now what we're going to do is learn how to find a weighted mean. Okay. So a weighted mean is going to be the mean of a data set whose entries have varying weights. And an example that we use a lot is, well, in this class, homework, I can't remember, I think is like 20% of your overall grade. So whatever your homework average is, maybe it's 87% or 93%, the weight for that particular value is going to be 20%, okay? And then the quizzes have another weight, the tests have another weight, etc. Now typically all those weights have to add up to 100%. So this is the formula that we're going to use. So to find the weighted mean, or X bar, for data that's weighted, it's going to be the sum of not just X, it's the sum of X times W. So what does this mean? Well, if you look over here, it's the data value times its corresponding weight. So if your average homework grade is a 93% and it's worth 20% of your overall grade, that's going to be 93 times 20%. And then you'll add that to maybe your quiz average times its corresponding weight. So if you had an average score of 73 on a quiz, on all the quizzes, and the quizzes are also worth 20%, and it'd be 73 times 20%. Okay, so you are adding or you're summing these products. And then you divide by the sum of weights, the sum of the weights. And this is where it typically should add up to 100. Okay. All right, so we're going to see an example. And I'm going to show you how you can do this in Excel as well. There's different ways to do it in Excel. It says, suppose that a student in Introduction to Probability and Statistics makes a 91% on tests. So that would be the student's average test score. And 85% on homework, a 73% on the final, and has perfect attendance. So perfect attendance would mean 100%, right? 100% for attendance. Then it says, according to the syllabus, the instructor has a weighted average where tests count as 50%, homework counts as 23%, the final counts as 25%, and then attendance counts for 2%. So we want to calculate the weighted average for the student. All right, so your data values, or the X's here, are going to be the actual percentages from each of those categories. So for the tests, it's a 91. For the homework, it's an 85. For the final, it's a 73. And for the attendance, it's 100%. Okay. Now I need to put in the corresponding weights. Now the weights are typically percentages, but you want to convert those percentages to decimals. So for the first category, tests, they are worth 50% of the grade. So 50% as a decimal is equal to 0.50 or 0.5. And then the next category is homework, and it is worth 23% of the grade. So 23%, which is the same as 0.23, okay? And then, what's this one? The final exam. It is worth 25, or 0.25. And then the attendance is only worth 2%. Okay? Or as a decimal, 0.02. All right, so if you look back up here at this formula, once we know the data values and their weights, we need to multiply them together. And then we sum up all those products, okay? So that's why I have this chart. Now we're going to multiply the data values times their respective weights. So you may have to use the calculator on some of this. 0.5 times 91, I believe, is 45.5, okay? But 85 times 0.3, I'm going to have to use a calculator on that one, guys. Okay. That is 19.55. And by the way, you don't really want to round until the very end on these. And then 73 times 0.25. You get 18.25. And finally, 2% of 100 is just 2. Okay. Now, we need to find the sum of these products. Okay. Which means I need to add up this category, or this column rather, the sum of the products. So if I were to add all these up, do this in the calculator. Okay, so I've got the 18.25 already in there, so I'm going to say plus the 19.55 plus the 45.5 and plus the 2. If I do that, I get 85.3. And I also want to sum up my weights. Okay. Well, if I sum all these up, I will get 1, which is the same as 100%, by the way. But you're only going to be using 1. Okay. So the average, according to that formula, is the sum of the products divided by the sum of the weights. Well, the sum of the products is 85.3, and the sum of the weights is 1. And 85.3 divided by 1 is 85.3. And that would be the percentage, or that would be the grade for that particular student. Okay. So these, if you want to do by hand, they're not all that bad. Now, I do want to show you how to do this in Excel, or one way to do it anyway. So I've got the data. My X's are right here. My weights are right here. And what I'm going to do in this third column is multiply these, just like I did in that table before. So the way you can do this is come to this cell right here. You're going to say equals, equals, and then you're going to select this first cell, and you're going to say, you're going to say times, and you're going to select that second cell, and you're going to hit enter. Okay, and it'll give you this value, which we got. Now, you don't want to have to do that for every single one of these. So what you can do now is you can come right here, or actually you can highlight, this cell right here. You can come down here to the lower right where there's that little really small square there. You may not be able to see it. But when you get these crosshairs with your cursor, you click and you can drag this down. And what this does is it takes this basically the same function, and it performs it on all these others except with these new cells. So instead of doing G2 times H2, it now for this one it does G3 times H3, and then G4 times H4, okay, and gives you this column right here. And then what you could do if you want, you could click right here and you could say equals, and you could come over here and you could find the sum, because what I want to do now is sum up this column. So then you could drag this cell and pull it down, hit enter, and it will give you the sum of that column. And then you could come over to this one and do the same thing. Type in equals, select sum again, highlight that column, and hit OK, and it'll give you that. Okay, and then you could even tell it to take this cell and divide it by this cell to actually give you that weighted mean. Okay, so there's a lot that you can do with Excel, guys. So play around with that if you want to. And I think this will be a good stopping point for the first part of this video. We'll pick it up here in just a second. We'll see another example, and then we'll kind of finish up. Okay.